Graph the system of inequalities. Y is less than 2x minus 2, and y is greater than negative 1 half x minus 1. Okay, so in order to graph these, we graph each inequality separately, and then decide what the solution region for the system is overall in the end. So let's begin with the first one, which is y is less than 2x minus 2. Now, if we were to start off graphing this as a line, it would have a y-intercept of negative 2 and a slope of 2. So if we go up 2 and over 1, up 2 over 1, and just get a few points here, maybe go in the other direction as well, that's where this line's boundary is going to be. Now, the thing about the boundary is that because I have less than, and if I had a less than or a greater than, these represent exclusion. So we're not including the boundary. And so what we do is we graph with a dashed line. If it had been uh, greater than or equal to or less than or equal to, we would graph with a solid line. So just make sure when you graph this, you make it very clearly a dashed line. Now, we have to shade one side of the line or the other. In order to do that, we need to just pick a test value. And if the origin is available, that's a really easy point to use. And we just plug that in. So the y value of the origin is 0, and the x value of the origin is 0. So 2 times 0 minus 2 is just negative 2. 0 is less than negative 2. That's a false statement. And because that's a false statement, what we do is we shade the side opposite of the origin. So I'm going to shade this side of the line over here. All right, now that one's done. Now we'll go on to y is greater than negative 1 half x minus 1. And in order to work this, what we need to do is start like we did the other one and graph it as a line. So I'm going to use a different color just for you can see it easier. But then let's see, if I have a y-intercept of negative 1, that's going to be here, then a slope of negative 1 half. So I would go down 1 over 2, down 1 over 2, or up 1 back 2, up 1 back 2, and I'll get a few points here. Now, the next thing is this is just greater than, so again I would use a dashed line. Okay. So draw a dashed line through those points, and then I have to decide which side of the line is going to get shaded. So I'll try the origin, and the origin, this would be 0 is greater than negative 1. 0 is greater than negative 1, so that's a true statement. So I shade the side of the line that contains the origin. So I'm going to shade this side of the line over here. So what that means is the solution region is all the points in between those two regions. All right, I'll do my best to shade that in, but here what I'm going to do now is just erase the other two regions so that way it looks a little bit nicer. But there's the solution region. Now, if you're wondering how to do this with the way you graph online, let me pull up an example there and show you real. Okay, so this is certainly a different set of line equations, but the way we do them is the same. So the first line equation is y is greater than x minus 2. So you want to choose a dashed line or a solid line based off of the inequality. So we want a dashed line. Then what I would recommend is pick the point that is your y-intercept, so negative 2. And then we have a slope of positive 1. So then up 1 over 1, that gives me another point on the line. I'm done graphing the line. Now I just move my pencil here, that's on screen, into one side or the other. And that's where you just have to do the same sort of test to decide which way it's going to go. So if you choose the origin and plug it into this equation, you would get 0 is greater than -2. Since that's a true statement, just click there, and now that will stay shaded, and you finished graphing that line. So then the other line, y is less than -1/2 plus 1, it's also a dashed line, has a y-intercept of +1, and a slope of -1/2, so go down 1 and over 2. And then you have to decide which side of the line you want to graph or shade. So we'll try the origin again. So that would say, if you plugged in the origin here, that would be 0 is less than 1, which would be a true statement. So there you go. Now when you click, it will stay and you've graphed it. So at this point, the overlapping regions, which are in purplish here, that's the solution region for the system. So if I submit this now, there we go.